Okay, welcome back to Geoscience. This is 240 and more question with answer for geology. That is a review question chapter 2, that's classification and nomenclatures or namings of igneous rock. This is part 5 from question 6 up to 11. This is continue from the previous episode from part 4 to now. I am happy to the growth of my channel. Please come with me. If you have any question, suggestion, and part 5. This is very interesting question and answer. For this answer, I can prepare this question's answer based on this book. This book is very interesting book. That's the Principles of Igneous and Metamorphic Petrology. That is Johan Winter's second edition. Please, if you want this book, I will give you. Please write in comment section. This is a very interesting book. This is my best reference for this answer. Let us proceed. Question number 6 said that why does the QAPF diagram present problem for P-rich rock? P means that it's plagioclase-rich rocks. What are rocks? The reason is that plagioclase-rich rock challenge on the QAPF diagram due to what? The diverse composition what diverse means the different compositions that are in category. Because they can classified into what? Two. That is alkali feldspar and plagioclase feldspar. So the reason for that problem is the diverse compositions of the feldspar. Okay, what are the three phaneritic or that coarse-grained P-rich rocks? Okay, the three possible phaneritic plagioclase-rich rocks can distinguish based on what? Their mineral composition. These are include gabbro, diorite, and anorthosite. These are the three phaneritic plagioclase-rich rock. These three rocks are found in the same place during the identification or nomenclature or classifications based on this diagram. Okay, based on this diagram, the three phaneritic rock, gabbro, diorite, and anorthosites are found within the same place. The reason is due to the plagioclase rich. Okay. Okay. What are the three possible phenocrysts and how can we determine that is the three one that is gabbro, the three plagioclase rich rocks are gabbro, diorite, and andesite. Then we can distinguish this, but what reason? That gabbro, how can what base may they can be distinguished? How can distinguish that gabbro from anorthosite or from andesite? That gabbro is rich in calcium-rich plagioclase. Okay, gabbro is rich what? In calcium-rich plagioclase. We have seen this one. This is QAPF diagram. Means this one. This is plutonic or phenocryst. This one is volcanic. We will come. At this time, this is plagioclase. P means plagioclase. The three rock, gabbro, anorthosite, and andesite are found in this place, within the same place. So we can determine the three rock based on what? Gabbro rich in calcium-rich plagioclase, whereas diorite have low calcium rich plagioclase contain more intermediate, and the last one anorthosite means more than 90% of plage content. So the three rock, diorite and anorthosite, and that of the gabbro are the three phenocryst QAPF diagram P-rich rocks that fell in within the same place, and we can determine based on the plagioclase content on these rocks. Are you clear? Don't forget to become a member of Geoscience. Let us continue. Okay, so diorite and gabbro have more than 10% mafic and are distinguished based on the average composition of what? Plagioclase. The plagioclase in gabbro is defined as more anorthosite rich. That means greater than 50% what? Anorthosite means that 50% calcium rich rock, whereas the anorthosite contents of the plagioclase in diorite is what? Less than 50%. This is very important things. How can distinguish diorite from gabbro? So when you come to gabbro, the calcium content or the anorthite content in gabbro greater than 50%, whereas in diorite, the anorthite content less than 50%. This is the reason how can determine based on plag content. Don't forget this one. Okay, we can proceed to question number 7. What are the two contrasting plagioclase-rich aphanitic rock names and how they are distinguished? We have seen the phaneritic. We can comes to aphanitic or fine-grained P-rich rocks. We can list this one. That are the two plagioclase-rich aphanitic rocks are andesite and basalt. Okay. Don't forget this one. How can they determine? Okay, in IUGS means International Universal Geology System recommend a distinction based on color index or silica content and no on plagioclase composition. Okay, we can determine the rock based on what? The color index and silica content. Andesite is defined as a plagioclase rich rock either with a color index between below 35% or with greater than 52 silica content. The silica contents of andesites are 52 up to 66%. When we come to basalt, basalt has a low color index greater than 35% and has lower than 52% of silica content. So how can determine andesite from basalt? Due to the silica content, concentration of silica content and the color index. Basalt is more what? Black, but andesite is intermediate. The silica contents of andesite is between 52 and 66%, whereas the silica contents of basalt is below 52%. Okay, and it becomes black. These are the two pH aphanitic rocks. Don't forget this one. Okay, we can come to this the basic question number 8. This is very interesting for any questions and answers. Please follow me. Don't forget to become a member of Geoscience. If it is not clear, please write in comment section. I will answer the question if this question is not understanding. So question number 8 is difficult for most students in exam or in studying. So what would you name a rock in which the weight percentage of sodium oxide is equal to 2%, potassium oxide is equal to 4%, and silica content is equal to 49%? So in igneous rock, we can classify a rock based on IUGS classification and test diagram. You may know about test diagram, okay? We'll see. This rock can be determined test diagram, classify rock based on silica, based on the geochemistry. Geochemistry means based on alkali oxide, that is sodium oxide with potassium oxide versus silica content oxide. How can plot and identify and name this rock based on test diagram? We can calculate, can see step by step. Naming a rock based on its chemical composition means based on the silica, that's sodium oxide, potassium oxide, and silica content, by using test diagram. Test diagram means total alkali silica diagram. We'll start familiar with this one. So we need to plot the weight percentage of what? Sodium oxide plus potassium oxide versus what? Silicon oxide. However, we should note that the weight percentage used in test diagram are normalized to what? 100% without the water component, without another content, without water content. That means the only concentration normalized to 100% using sodium oxide plus potassium oxide with silica content only. So please remember this one. Okay, let us normalize the percentage first before determining. So the remaining the equation contain sodium oxide 2%, potassium oxide 44%, and silica oxide 49. But plus this one and 245% is what? Another component than this one. Okay, 45% of these rocks are another impurity or whatever low content or what that is impurity or another what minor minerals. So we consider only this one. This one is not important for ours. So now we will calculate the normalized weight percentage of sodium oxide plus potassium oxide and silicon oxide. Okay, let us calculate. Normalized sodium oxide plus potassium oxide is equal to, okay, we can substitute. So the result is 6%. And if we can normalize silicon oxide based on this formula, then that is the formula is that is sodium oxide plus potassium oxide over total percent. That means sodium oxide plus potassium oxide plus silicon oxide plus that is the other component. This times 100 is equal to what? 6%. And also in silica content, silicon oxide, just silicon oxide over the total times 100, we can get 49%. So how can this one determine the rock? We can see this one. Now let us plot. This normalized value on the test diagram based on the positions of the point represent this value. We can determine the rock type. So this is test diagram. The y-axis is weight of sodium oxide plus potassium oxide. We can calculate, we can get 6%, this one. So we can extend the 6% to horizontal, and then we can get the silica content 49% and draw vertical through the 49%. So they are meet here. So this region we call as what? Trachyte basalt. So this rock name we call as what? Trachyte basalt. Is that clear? If you have any question, please ask me. Don't forget to become a member of Geoscience. If you have any question, please write in comment section. This is the final one. So you can name the rock trachyte basalt, this region. Okay, because this value fell here, this region. Okay, let us go to the another best question similar to the previous one. That similar procedure we can take. Okay, that is a similar procedure in question number 9 also. What would you name rock in which the weight percentage of sodium oxide is equal to 5%, potassium oxide is equal to 3%, and this is equal to 58%. So let us also the same procedure we can take. This is the given one, and another component that is calculated by sum up this one and minus from 100, we can get 34%. This 34% is another component, like what I have said, that either impurity or another that is the low content or low concentration. Okay, not the major one. Let us go. Let us calculate the normalized weight percentage of this one, like the previous formula. The same to that one. Okay, normalized sodium oxide plus potassium oxide, this plus that sodium oxide 5% plus 3%, that is 8%, divided by the total plus 1 and is also the remaining one times 100, we can get 8%, and the silica content is equal to 58% by calculating that one. Let us plot this value on the test diagram. Okay, let us go and draw this one. We can get 8% of sodium oxide plus potassium oxide and extend this through the 8% to the horizontal, this one, and also plot the weight of silicon oxide to the vertical one. That is, we can get 50, I think 50 8. So 58 and 8% that they can meet in this region. This region because this concentration, this oxide concentration rock fill this region. The name of this region trachyte andesite. So the name of the rock is trachy andesite. Is that clear? Okay, let us proceed to the next question. Question number 10. Also the same to the previous one. We can follow the same procedure. What would you name the rock in which weight percentage of this one? Let us get another component 39% and this is the given one. Let us calculate weight percentage, the same to the previous one. We have get 8% of sodium oxide plus potassium oxide, this one, and you can get 53% of silica content. Okay, let us proceed to plot this value. We have get 8% of sodium oxide, weight percentage of sodium oxide to potassium oxide here, and extend the this weight percentage to the horizontal, and also the vertical value is 53% of silicon oxide to the vertical, and they meet here. So the name of the rock equals basalt trachyte andesite. Is that clear? Don't forget to become a member of the Geoscience. If you have any question, please don't forget to write in the comment section. If you have any comment or suggestion, please write to me. Let us proceed to another very interesting and very important question, question number 11. I am surprised to this question, okay? This question is not, it is every question or every geological exam seems like this question. If you know this, how to calculate this percentage value and how to know this one, not to be confused to calculate another in the exam. Okay, what said the next question, that is the question number 11, said that, what would you name a rock containing 60% ash, 30% fragment between 3 and 50 millimeter, and 10% fragment over 64 millimeter, if it were a light pink color? Okay, in igneous rock, there are three types of rock. Igneous rock can be classified into three. That's volcanic, means the rock that is formed from crystallized from lava, and also there is pyroclastic. Pyroclastic means a rock that is formed from the depositions of, that is the lapilli ash, and that is the bomb, or that is large fragment greater than 40 block or bomb. That's just these are the pyroclastic rock. So this rock is types of pyroclastic rock. So in pyroclastic rock, we know the material that is ash, that's lapilli, and blocks or pump. Okay, we have seen that. This is the basic one. If the grain size or the size of the fragment, pyroclastic material, greater than, or the radius of the pyroclastic material greater than 64 millimeter diameter, we call as bomb. If a molten during what? Fragmentation, during evaporation, or during explosive reaction, that material is molten and the diameter greater than 64 millimeter, we call as bomb. If the reverse of that, the same size, but they cannot molten during fragmentation, we call as block. So bomb means molten during fragmentation, whereas block means solid during fragmentation. The only difference is the state, but they have the same size. And the size greater than 64 we call as bombs and block based on their molten content. Between 2 and 64 we call as lapilli. So this question said that 30% fragment between 3 and 50 means in this region. So this one is lapilli. Then go less than 2 millimeter means that this 10, that is 60% ash. Ash means less than what? 2 millimeter. This is very interesting for any geologist. Please know this one. This is correlated to for sedimentary, clastic sedimentary rock. As we can in clastic sedimentary rock, that is the size of clay seems like ash, and the size of what? There is sand similar to lapilli and the size of gravel similar to what? Bomb sand block. Okay, let us calculate this one. If you know this one, let us go here. This is a given one. Okay, let us. We can normalize it based on the condition what we have now. First of all, the horizontal x-axis, this one, this is the diagrams of the block. We know that this is pyroclastic rock classification diagram. This is very interesting. Please know this one. This is ash, this lapilli, this one is blocks or bomb. We know that we have discussed about what means blocks, what does mean blocks, and what does it mean bombs. So first of all, to be draw this one, this x-axis means calculate based on this formula. Ash times 100% over lapilli plus ash, this is the horizontal one. We can get 66.7 what? Percent value. So we can go from the left to the right, count 66.7% here. So below the 75, and that is between 25. So around this region. And extend the line to the vertical one. You can get this one. And we have get 10% of what? The 10% of fragment over 64 means this one. 10% means count from this horizontal. So this value below 25% here. So the region is around here. Then extend this line to here, and this vertical, they can meet in this region. So this rock value, this rock name we call as lapilli. Is that clear? Don't forget to become Geoscience. Please write your comment or your suggestion in comment section. Thank you more. This is Geoscience. Next, we'll start new chapter, chapter 3, textures of igneous rock, from question 1 up to the next question. Thank you more for your times, comment, and suggestion to be a member. I am happy to your comments and your suggestion. See you next.